Now, how many people here were at my talk that I did yesterday? So we're not going to talk about 8 lines of code today because most of that was actually discussed yesterday. It's literally like half of it was the same talk. So instead, what we were going to talk about is production lessons. How many of you have actually put software in production? Production is completely different than when we talk about things in dev. And we're going to talk about all the kinds of fun issues that come up in production and how to deal with them. How many of you have had a bug in production? You want to minimize those, right? And there's a way of doing that. It's known as Six Sigma. How many have heard of Lean and Six Sigma? This is an entire framework for going through and trying to reduce the number of failures that we get. When we talk about Six Sigma, it actually looks to get 6 standard deviations of quality. Can you imagine that? 6 standard deviations. So in other words, if we were to have 1 million opportunities for failure, we expect to get 3.2 failures out of that. That sounds really good, right? Okay, so the last place I did this talk, they were doing 300,000 requests per second. If you reach 6 sigmas of quality, where does that leave you? I know what we should do. We should make all those errors email you. You're only going to get about 1 a second. When we start going through and we start looking at these kinds of systems that are in production, very often 6 sigmas is a joke. 3.4 failures per second isn't a good thing. We need to go way past what normal people start looking at for quality. Now, I've been using this word failures. I want you to forget the word failure. And instead, I want you to use the word fish. And at the end of the day, it works out so much better on your team when you talk about fish. Don't use the word failures anymore, use the word fish. And you say, today we had 1,056 fish. And the other part of this is you get cute pictures. I mean, what could go wrong? But it sounds so much better on your team when we talk about having fish in production, as opposed to talking about failures, and you'll feel better when you go home. But when we talk about 6 sigmas and trying to reach quality, the 6 sigma methodology is a really nice one. And basically the way it works is on this slide. Define, measure, analyze, control, improve. This will reach higher levels of quality than what you guys would be getting otherwise. And keep in mind that there's a lot of systems that are out there where even reaching 6 sigmas it's a joke. You will have a failure once per second at 6 sigmas of quality. But it is worthwhile to go talk to those business people that you may happen to work with. They have methodologies for how to actually reach quality in production. So let's move on to the next thing. Math. How many of you have measured performance of something before? How many of you have seen something like this before? Our average latency at the 95th percentile is 20 milliseconds. That's fucking meaningless. It sounds really smart, but it basically says, I know nothing about statistics. Go through and learn the math. Learn what it means when we talk about how to do measurements. How many of you use percentiles a lot? What I tend to see is people like to give me averages. Averages are meaningless. When you go to measure something, go through and do it based on percentiles. Go take a class, and I know a lot of developers, they like to feel that they know everything. Spend the effort. Go take a class in basic statistics if you don't know it. There are so many not precise sentences that you will hear when people are talking about production. I've worked as a consultant with many companies who wanted to improve their performance, but they didn't know how to measure it. Understanding how to do measurements is a really, really important concept. Once we start getting into systems, very often we try to abstract things. How many of you have used layers of abstraction? They're great, right? until they're not. Abstraction is a beautiful thing until you get to production. How many of you have used some small abstraction and then ended up wasting, let's say, 3 months in production trying to debug an issue that was caused by that abstraction? But think about all the time it saved you up front. You ended up saving at least an hour or two up front, but it cost you later. And we've had some examples of this inside of Event Store. One of my perfect favorites was filestream.flush. How many of you would expect filestream.flush to not work? So we ended up inside of our production testing, and what we do in production testing, we're going to talk more about this later, we actually have a cluster where we physically pull out the power. And what we started finding was about 1 time in 5,000, it would fail. Shit. And we ended up tracking back the issue. Now keep in mind, the only thing that we get is we get a power outage failure, and then we have corrupt data afterwards. So where do you start on debugging this? See, this is one of those production issues. And what we ended up finding after months of looking at this problem, because remember, how long does it take for you to unplug a physical machine and for it to boot back up again? This would happen about 1 time in 5,000 of doing that. By the way, how many of you have used a step debugger before, like Visual Studio or IntelliJ? How much is that going to help you in this case? So we used to have this thing we used to do. It was called philosophical debugging. You would open the code and read it. So what was the problem here? Well, we were calling filestream.flush, and we were passing true. That is supposed to flush it down to disk. It's supposed to do an fsync or a flush file buffers in Windows. But FileStream had an internal buffer. And basically, when you wrote to the file stream, it would write to the internal buffer, which might, maybe let's say 4096 bytes. And then what would happen is you would call flush. And it's supposed to flush the buffer down to the disk. But there was an if statement there. It said if buffer.count is greater than 0. So what happens when you go through and you do a write? So I write exactly 4096 bytes into it. That fills up the buffer, and it goes, my buffer is full. I will internally call flush false right to the kernel. Now, I explicitly call flush, and it goes, oh, if buffer size is greater than 0, what's my buffer size now? 0. Then don't flush. It took us months to find this issue. But think about all the time that we saved as opposed to using the operating system calls directly. We had another one of these. Filestream.seek. Who would expect this to not work? And what we found was we had to start sprinkling in filestream.seek 0. Why? Because there were differences between Mono's file stream and Microsoft's file stream. But think about all the time we saved because we didn't go call the OS calls directly. We must have saved at least 2 or 3 days, and we paid for it with about 3 months worth of debugging. And this is a big problem. When you start working in production, you tend to want to go through and look at what system calls are being made. But then you use an abstraction. And that abstraction hides from you which system calls are being made. So you end up with 2 different mental models. And bridging between the 2 mental models is actually a really hard thing to do. How many of you have reported what system calls you were actually making in production to try to debug something that was going on? This is like the gold standard for how you deal with things in production. What we're lacking here is transparency. And when we're in production, we basically want to look at things from an operating system level of how things are actually interacting together. When I am in dev, I work with abstractions on top of this. And because of that, we have a hard time connecting the 2 mental models. And this brings us to the other thing that we tend to get in production. Virtualization. How many of you run in a virtualized environment today? And I remember people coming and telling me about all this stuff. that virtualization would solve all of our problems. And of those promises that are there, how many of them actually came true? So I can tell you right now, we've got some nodes in Amazon that are C3 8x large. They're supposedly with 32 CPUs, 60 gigs of memory, and about a half terabyte of SSD. But oddly, when I go and I look at those, this laptop outperforms them. How does this work? I have 32 CPUs versus one CPU running locally. Okay, given it's got 8 cores. But that should be 4 times faster than my laptop. But when we actually go through and we use it, it's not. Another one here, high availability. How many of you think the cloud is high availability? Like, isn't the whole point of us doing this whole microservice thing so that we're anti-fragile because the cloud is fragile? And how many of you think this has seriously reduced costs? Almost every single promise on here is a lie. And what we're missing, again, is transparency. We get this all the time at Event Store where people are going through and they want to do performance testing. And they get curious because it's like, well, I ran it on my laptop locally and I was getting 50,000 transactions per second. But when I ran it in the cloud, I was getting 10. So obviously the database is broken. This must be the problem. How many of you have gone through and looked at what is involved with doing file system write to a file? And comparing that on your local machine to what happens in the cloud. It is immensely complex when we start adding in levels of virtualization. Trying to optimize code in the cloud is next to impossible because there's so many different levels of abstraction, and you probably are only aware of about half of them. At the same time, when you call fsync, what does fsync do in the cloud? Trying to figure out when data actually is written to a disk is next to impossible. And these are kinds of issues you will only find in production. But it's funny for me that when I go and look, almost all the promises that were being made about virtualization have oddly ended up being false. Be very, very careful using virtualization. I would go far enough to say that if you have something like a database, don't run it virtualized. You probably don't even understand the complexity that you're bringing into the problem. This old machine. This machine I programmed the operating system for when I first came out of university. It was great. I got to go as my first team. I was one of 2 guys that were under the age of 35. It was literally an entire team of graybeards. And we built devices, and we built the back-end system that monitored and basically managed gambling inside of horse tracks in America. Things were different back then. They were good old days. Like, in order for me to release software onto this thing, I actually had to physically go back to engineering and burn an EEPROM. And I mentioned earlier that we had come up with this thing that was called philosophical debugging. And I think today we're spoiled. How many of you step debug on a regular basis? Yeah, you hit F10, step through, look at what the variables are. So we had a debugger on this. It was a VT100 that was connected to a serial port. And what would happen is you could put log messages in and they would come up on that VT100. And when we wanted to go release software, as I mentioned, we had to go burn an EEPROM. So what would happen is you would be logged into one of our VMS servers and you would make a code change, let's say to add a log message. You'd build it and that would make you a .bin file. You would then get up and walk about 150 meters that way. Take a physical EEPROM, put it into the burning machine, load up Intel's burning software, go find the thing off the cluster, and it would take about 3 minutes to actually burn off the EEPROM. You would then take that EEPROM, you would go back, you would open this machine up, take out the old one, put in the new one, and turn it on. How many of you think this is an efficient debugging task? So what was interesting was when we had to do things this way, we started doing this new kind of debugging. It was called reading the code. And it was quite common, in fact, that we would actually go and print out the code, and 2 or 3 of us would go sit at a table and talk about it. And this is true today as well. And we're getting spoiled by working with step debuggers. And at the end of the day, when you go to production, your step debugger is probably useless. All of your interesting failures that are happening, your step debugger is not going to help you with. How many of you had a production failure that you couldn't debug? I don't know, maybe threads were involved. Maybe it was a crash, and it's already crashed, so hooking up the step debugger won't help that much. How many of you have written code in C? So seg faults, your debugger is going to help you a lot with that, right? The thing is, we have lost and we've become spoiled using step debuggers. Debugging is an art, and it's an art that most of the new people are not learning. How many of you guys know Uncle Bob? So we had an interesting conversation a while ago where he was basically explaining right now, about every 4 years, the number of developers doubles. Can you imagine that? So what happens if you have 12 years of experience now? Where does that put you if it doubles every 4 years? 4 years doubles the number of developers. And what we're talking about is things that they're hard, and they're an art, and you don't learn them in your first 4 years. Remember this when you start looking around at all the developers that are around you. Every 4 years, the number doubles. And when people talk about a 1% developer, well, they're basically just talking about somebody that has like 12 to 15 years of experience. If you are in the top half of those people, you're probably a top 5% developer at least. But remember, we're talking about that math stuff, and make sure to remember that math stuff. But when we go through, logging, it's not the answer for all of our debugging problems. And it's just not going to be enough for you. And this is one that we've worked really, really hard on with Event Store. Just doing a log, it's not going to be enough to give you what you need when it comes time to debug a production issue. Logs are great, but they're not enough. And if you make this mistake beforehand, you will never fix it. From the very beginning of your project, think about what you need when you have a real production issue. So somebody sends you this package of things. Maybe logs are part of it. Maybe memory dumps are part of it. But what will you need to debug a production issue? And get that going from the very beginning of your project. You cannot put this stuff in later. When you have a failure inside your web server, what things do you need to be able to debug that? Figure that out from the beginning of your project. This should be your day one thing that you're figuring out. What do I need to debug production issues? Automate it and make it so that it can package it and give it back to you in the case of a failure. Again, if you don't do this at the very beginning of your project, this is not something that you can strap in later. It needs to be done at the beginning. Another one, make sure that you print off your environment variables and your effective configuration into your log. How many of you have had people making configuration problems with your software? Or if you have configurable software and they're having an issue and then you start saying, what is your configuration? And what happens? They lie to you. And I actually have an example of this that we can look at really quick. Let me just change my display. Let's go for mirror. And hopefully this works. Okay. So what I'm going to do now is I'm going to run Event Store. And you'll notice here the first thing that we do is we print out what all of your effective options are onto the screen and into the log. Why do we do this? We do this so that when you send me a log, I can read this first. What is your effective configuration inside of your log, and where is that configuration coming from? Is it defaults? Were they on the command line? Were they from environment variables? You'd be amazed how many times people get confused about this stuff. And like they'll have set an environment variable, but then overridden something else on the command line. And then they wonder why their environment variable isn't working. This easily allows us to go through and to figure out what your effective configuration actually is. And this is, again, something that we built at the very beginning in order to get this working. And this helps us debug production issues. Our single biggest thing that we have to debug is people's configuration problems. Remember what you need when it comes time to do a production issue. When somebody says, well, this stuff's broken, what do you need in order to disprove them or prove them right? And to be fair, when you actually work in production, a huge portion of your job is just to disprove people. Chances are the problem is actually them, but you can't say that. The chances are, like if you go download Event Store, and we have this happen all the time, and people will be like, oh, my writes aren't working. I just downloaded it for the first time. And it's like, well, what's the probability here that Event Store is uniquely broken for you, as opposed to, the other 1,000 production instances that are running, versus it's some kind of configuration problem. And then the majority of what we have to do as support is to disprove that we're broken. What do you need to disprove those people? This is a huge part of what you do when you're actually talking about doing production level support. Now, how many of you have used Azure? How many have used AWS? I would prefer AWS at this point, mostly because I can script the crap out of it. When we talk about doing production level stuff, if you cannot automate it and you cannot script it, it is not a tool you should be using. If it involves you opening up a web browser and going and clicking on a button, just get the hell away from it. This is one of my main deciding factors when I start looking into things in production. How scriptable is this? If it is not scriptable, I don't want to touch it. And you'd be amazed how many systems out there are not easily scriptable. This is not uncommon. But be very careful about anything in your tool chain that you cannot involve with scripts. How many of you have had a production issue with performance? Those suck. And there's one single thing that will almost always cause performance issues, especially when we talk about latency issues. It's known as a queue. And queues are wonderful. They are one of the best inventions we've ever come up with. But they also cause a lot of problems. When you have a queue in production, never, ever, ever leave it unbounded. What happens if you have an unbounded queue and you produce faster than you can consume? You get this guy. It gets bigger and bigger and bigger and bigger. And your latency gets worse and worse and worse and worse, but you keep running. Until eventually you run out of memory or possibly disk. And basically you blow up the entire system. There are many ways of bounding a queue. One way of bounding a queue is to use a fixed size buffer. And basically you never allow more than a certain amount of data inside of there. A great way of implementing this is known as a ring buffer. What happens when you try to write to a ring buffer that's full? You block. And this bounds the size of the queue and it puts back pressure off onto the producer. When we talk about this is even more important when we start getting people, how many of you have played with Akka or Erlang? Yeah, no hands for Erlang, of course. Everyone here is a Java developer. The main thing that you should be looking at in such systems is the size of the queues, how you bound them, and how back pressure works inside of your system. Anytime that you go and look at this kind of system, the first thing you should be thinking is, how does this fail? Not how does it work under normal conditions. And almost always, you will find that your performance problems are actually in these queues. And these queues always should be monitored. It is of the utmost importance that you monitor every single queue inside of the system. This is where you will find all of your performance problems. Queues are great until they're not. And this also includes all your operating system level queues. You should be looking at your disk and what's going on with your disk queue. If you're having I/O problems, you can almost guarantee that's where it's going to be. You should be looking at TCP, networking. All these queues inside your system need to be monitored. Otherwise, you will never really figure out where your performance problems are actually happening. I cannot stress enough that queues, although they're a great data structure, they're also the number one spot where you're going to end up with latency problems. And understanding where they are is very important. As I mentioned before, logging is not enough. Now, how many of you have, again, used step debugging? So I am going to make an outstanding claim. I am going to say that most interesting problems cannot be step debugged. The only thing that you can step debug are trivial failures. How many have tried using a step debugger with multiple threads? How'd that turn out? Even better, multiple threads that happen to be running through the same piece of code, because that's always fun when you put a breakpoint, right? How many of you had the fun problem? You know, the one where the problem, you can make it happen deterministically until you hook up a debugger. And once the debugger's hooked up, you cannot make the problem happen anymore. These are fun issues. Beyond that, though, I will say that when we talk about production issues, most of them are actually cascading problems. There's multiple concurrent problems happening that actually bring out the interesting problem. And when you do this, step debugging, it's just useless to step debug. Instead, you have to go back to the way I was taught 15 years ago when I first came out of university. Print the code out on a piece of paper and read it. Because you're going to end up with multiple things going wrong, and the cascade is the interesting part. And trying to get the cascading to happen inside of a step debugger is likely impossible. Along with this, how many of you have ever done a memory dump and learned how to open and debug inside of a memory dump to figure out what's happening in a failure? This is one of the most crucial things that you need to get pushed out to you, is a memory dump when you are actually in a failing mode. Go through and learn how to actually get in and read a memory dump. I know it's hard, especially if you're using GDB. It's a nightmare to learn, but it's worth it. And you need, when you're talking about production, to be able to get into a lower level in terms of what you're dealing with. Very often, even when you're running something in the JVM, the issue that you have needs to be fixed from a C perspective. And you need to understand the underlines of what's going on. So, how many of you write unit tests? Unit tests are supposed to help you get better quality, right? Now, unit testing has absolutely nothing to do with quality. Unit testing is about having a safety net. And I go to way too many companies who they try to base what they're doing on unit tests. Unit tests are a really, really poor way of ensuring quality. Because unit tests, they only test what you have written tests for. How many of you have had a bug that came up in production that you didn't have a unit test for? So how come your non-existent unit test didn't find it? When you go through and you want to start reaching levels of quality with testing, it's a different mindset than unit testing. Unit testing can show that this scenario works. It can't show that it doesn't work in some edge case. There's another way of doing testing that's much, much more effective when we talk about wanting to reach quality. It's known as property-based testing or randomized testing. How many have done randomized testing on your system? Almost no hands. This is what you should be doing in order to reach quality. You take your system, define a model around it, and then what you do is you throw a whole bunch of random crap at your system. And you make sure that it stays in the model given a bunch of random crap. This is also a very easy way of doing testing. Very often I can come into a system and I can define a model in only a few lines of code where you would need 7,000 unit tests to show the exact same thing. An example of this would be Paxos. But before we get into Paxos, let's try what we do with Event Store. So when we define a model, what we do is we basically say we're going to have a writer that's writing into the database. This writer can have, 100 threads working concurrently, and he remembers the state of each transaction that he's doing. So a transaction could either be written, it could be in process, or it could be I've never actually done it before. When we say that this thing has been written and I go do a read, I expect that this thing must be able to be read back. Otherwise, that would be a bug. When we talk about it being in process, the read may or may not work. It's non-deterministic. And if I've never written this thing before, I damn well better not get back a read for it. That'd be really weird. So we define this model, and then we run 500 billion times. And what I'm looking for is any failure in any of these. Think about how many lines of code it is to build up a test like this. It's very small, very succinct. And then we introduce randomized failures along the way. So what happens if I start pulling out the power cable while this is happening? What happens? So now my test pauses, I put the power cable back in, bring back up the node. All of this stuff in the model should still be true. Let's try another kind of failure. What happens if I start pulling out network cables while I'm doing this test? And this is how we actually do this kind of randomized testing to reach much, much higher levels of quality. Another example of this, and by the way, if people haven't seen this before, that box over there in the upper left-hand side, that is actually an automation piece that we send HTTP messages to physically pull the power out of the nodes while we're running these tests. Now, people ask, why do we run these tests? Well, how many of you have had a power failure on a database server before? And then you freaked out, right? You were scared. You know what? I fully expect you to come and pull the power out. And you know what? That's a perfectly valid mode of shutting us down. And we've tested this hundreds of thousands to millions of times. We have 24 365 nodes that do this all day, and they run this test. I am not afraid in the slightest if you pull out your power. Well, let me rephrase. I'm not afraid that it's our problem. Depending on your levels of virtualization and where you have your caching going on, it quite likely may be a problem, but it's your problem. And I have enough to disprove you, to show you it's your problem now. But another example of this. How many of you have heard of the scariest algorithm on the planet? It's known as Paxos. No human could ever understand this algorithm, unless, of course, you do it with tennis balls. Then it's relatively simple. Paxos, if you want to go through and you want to unit test it, is roughly 6,000 to 7,000 unit tests you would need to write. However, I can describe a model of Paxos with my nodes, and I can do that really, really simply. It's basically this. We're going to run an election to a depth of n. At the end of that depth, one of two things should happen. Either a majority of the nodes believe they have made an agreement and they agreed on the same thing, or nobody should think they made an agreement. It's really simple to define the model from the outside. And then what we do is we put a thing in between them. We call it FlakeNet. And what FlakeNet will do is it'll randomly mutate, lose, or multiple send your packets between them. Bring it up in memory, run it 500 billion times. Chances are, if you're going to have a problem, this will find your problem. And this is a very simple way of writing these tests. Going through and writing tests for Paxos is really, really hard. There are so many possible edge conditions that exist. But doing it this way, I write one test. That model is very simple. You can come in and you can understand my model. And there's tools for doing this. If you go off and you happen to be in the Haskell world, there's a wonderful thing called Quick Check. And Quick Check has been ported to many other environments. This kind of property-based randomized testing, this is what you want to do to be avoiding production issues, not unit testing. And I'm not saying that unit testing is stupid and you should never do it, but it's not being done for quality. For quality, randomized testing will do a far better job than something like unit testing. But again, all of these things, they all come back to this is stuff you only will find in production. And when you're in production, you need to have a different mindset than when you are in dev. You need to be more of a system administrator and less of a developer. You need to think about how to break things and think about how things break. When this failure happens, what other cascading failures can it introduce along with it? And you don't do things like step debugging. You spend more time looking at things like logs and memory dumps. But to summarize some of the things we've been talking about, I know it's hard to admit that you don't know math, especially as a developer, but go and take a math class if you don't really understand statistics. If you don't understand concepts like variance, take the couple weeks. I'm sure there's one up on Coursera that's taught by a brilliant MIT professor. Go and take the course. Otherwise, you'll make a lot of mistakes, especially in terms of measuring things. And as a whole, developers are really, really bad at measuring things. Oftentimes, the measurements that people are doing are measuring the wrong thing. I went to a talk about 2 months ago where they were doing performance testing. And the numbers they were showing were throughput, but all they had managed to measure was latency. And they didn't realize what was going on inside of their numbers and why they were complete garbage. This is very common, that we don't know how to measure well as developers as a whole. But go and take a class on basic statistics and how to do measurements and what measurements mean. I cannot stress how important that is. And avoid abstractions. I know we love abstractions, and we've had this thing called reuse that has been our pipe dream for the last 3 decades. Have you noticed how little things actually get reused? But we chase this goal of trying to get reuse into our code and making things more and more levels of abstraction on top of levels of abstraction on top of levels of abstraction. As I mentioned before, how many people here actually understand the process when you call file.write between yourself and the disk? And it's a very important thing to actually understand. The other side of this is when you're in production, what's going to end up happening when you start looking at dumps or you start reporting what your system calls are, it will become a layer of abstraction on top of that as well. And sometimes abstraction is good, other times it's obfuscation. And I'm not saying to avoid abstractions all the time. I'm not telling you to go write your own linked list every time you need to use a linked list. What I'm saying is that when you have places that you really care about, avoid abstractions in them. Go directly to your system calls. It sounds like it's going to be slower and you're going to lose a lot up front. But what you've lost up front, you'll more than make up for later when it comes time to do things with debugging. And it's very common that you'll end up with a very tiny little issue that ends up taking 3 months to debug in production because the issue is in one of the areas of abstraction between you and the thing that you are working with. And it may not happen regularly. Like, for example, the one we had where it was 1 time out of 4,096. By the way, who wants to debug that problem? It'll be fun, right? How long does it take a server to boot? Okay. So let's just say it's like 1 minute. So every 5,000 minutes, you're going to end up with this problem once. Great. When you go through and you're trying to reach quality, the best way to do this is to define a model and then make sure your code stays within that model, given randomized failures. And what you test is that your code is staying in the model with all this kind of random crap happening. This will go much, much further towards reaching quality and avoiding production issues than you will get with unit testing. And I want to stress again, I'm not saying that you guys should all throw away your unit test and never unit test, and unit testing is stupid. What I'm saying is that there's other forms of testing that will actually do a better job when you want to get to quality. And I mentioned it before, this needs to be done within the first week of your project. Think about what happens when you get a hairy issue in production. What will you need to debug that issue? Make it so that you get it and it's automated and packaged up and it comes to you with that issue. Otherwise, you will never get the information that you actually need. It is the best way of dealing with production issues. It's that you've thought up front about what you need to debug a production issue. And this can include memory dumps, logs, configuration. But think about up front what you're actually going to need to be able to support a person during a hairy failure. And yes, this becomes even more difficult when you start talking about microservices. I know they're the new hot thing, but there's a tax there, because now you need the logs from like 12 machines. And you need to piece them together. And I know now people are going to build a new microservice log collection microservice. And I really feel like I need to put the trademark whenever I say microservice. And if nothing else, remember fish. Does anyone have any questions? They are, but they are much less done abstraction. Normally, they are so heavily tested that they're going to turn out much better than your higher level abstractions. And there can be. My rule of thumb, especially when I'm dealing with, let's say, the Linux kernel, is that if there's a bug, I assume it's my problem first. And I actively try to prove that it's my problem. Sometimes you'll get in and you'll find out that it is actually a Linux bug. But this is relatively rare for most of the mature system calls. As an example, using a memory mapped file, the chances of it being your bug are like 99.999% as opposed to it being a kernel issue. Any other questions? Oh, sorry, I have a hard time seeing if people are handing their, because I've got a light in my eye. I think it depends on the software. Some systems, it's much better to actually have a production team where basically we give our software to the production team and the production team maintains it in production. And basically they are a gate to us. So when we give them software, they actively try to break it and come back to the developing team. When we talk about something more like a typical business system, absolutely, I think it's probably best that the dev team owns it in the entirety. And basically, the dev team is also the production team, and they're actively working in production as well as in dev. But for something more like an operating system or a database, then I would actually want to have a separated production team as opposed to a development team. Any other questions?
What should I do when my randomized test fails?
So it depends on which randomized testing framework that you're using. So you have managed to find that there is actually a failure in the system. So how do we walk back from that? And it depends how we're doing our randomized testing. As an example, if you're doing power pull testing, like what we were doing, there's no easy way of doing that. Basically, you're left with, here's what the logs are, here's what's on the disk when I came back, and it's bad. And you have to debug from there. If you're doing something more like randomized testing on typical business type code, then if you're using something like a quick check will actually, once it's found a failure, it will reduce it to the smallest number of steps possible to reproduce the failure. And basically, at this point, you now have a reproducible failure, and you can try to figure out what's going wrong. If you're just running in memory, you might be able to come in with a step debugger here. If you're running with multiple threads, of course, this can get hairy. It really depends on the type of failure and the type of model that you're defining. Any other questions? Well, then I will thank you guys for coming out, and please don't forget fish.